Hello, today we will work with a file from airport site monitoring. We have a record of 3 days. I've just opened the file. It contains data from a monitoring station nearby our airport. We can expect to see lots of aircraft passing events all over this file. What we will do today with SvanPC++ is a common task that we are expected to perform in case of airport noise monitoring, which is firstly detecting, finding aircraft passing events in the time history, and next calculating SEL values for each event, as well as LVA parameters for the each 24-hour period evaluation. The first step is surely to detect the events of passing aircraft. There are multiple methods possible to do that. The one we will follow today is to refer to the background level, to the statistical background level in particular. So let's start with calculating L95 value. I'm choosing to calculate LEQ statistics from Environmental Calculator tool. I go to parameters to verify that I will just see L95 in the logger results view for my convenience. And next I would choose to calculate the statistics hourly, so that each not too long, not too short period of time is going to be assessed separately. Alright, calculate. First, SvanPC++ will show a histogram view of the statistics. We don't need it for our evaluation currently, so I'm just closing the view. And coming back to the basic logger results view, I could add L95 to it to see that the statistical levels, background statistical level L95 is shown all over the data. So now we can use a blocks marker generator tool to auto detect the events in the time history. We will search for these events all over the data we have, and our conditions for the search will be so that the LEQ is greater than say 24 decibels above this statistical L95 level. Of course, some kind of the parameter we would like to use is up to our assessment of the measurement data in a given situation. Each monitoring station might have little different parameters it needs. What's also important is minimum and maximum duration of events we are looking for. This is to filter the situations in which actually it is only just a short and sudden loud noise or perhaps not characteristic to a passing aircraft, as well as if it's some long steady noise, it's also possibly not a passing aircraft. That's why we also apply a limit for the maximum duration of an event. In the last step in the tool, we will select how to call these ranges found by the tool. We will call it like 24 dB above L95, for example, to be clear. what we have with what we have chosen here. After the SvanPC++ does its job, we can like focus on one of the events that many of them have been found here. As you can see, these dots in the aggregated view. I will magnify the data around here, and let's have a look at some case of where an event is found. This is right here. Here we have some. This indeed looks like an event of a passing aircraft. So it might be a good event found. This one, for example, it is apparently at least 24 decibel above the statistical level. However, for too short time. That's why this noise here is not marked with our marker. What we should actually do at this step would be to go through these auto-detected events and probably verify if this auto detection is correct or not. We can compare the ranges found with our timetable of flights, or perform some other form of verification for the events found in the time history. However, we will skip this step for our tutorial. And we will assume that the events have already been verified, and what we will do next is we will find the maximum values for each such event in the time history we already have pre-selected. So let's go back to the calculator tool. I will clear settings to start from scratch. I will choose LMAX with parameters like searching just among the events that we have selected, and I would like to have a separate result for each such event, so I choose don't accumulate among these options. Alright, to calculate, I have LMAX value for our event we had a closer look at. Let's see now. The next step is, as it is usually required by the regulations, by the authorities. It's necessary to calculate, to choose the events which are like exactly or not more than not less than 10 decibels below the maximum level. So that's the motivation to use this blocks markers generator tool again. This time we will find the moments when LEQ is exactly equal to the LMAX, to the maximum value, and we will search for we will choose the time range where until it is more than 10 decibel below LMAX. That's why I will choose such parameters here. I'm referring LEQ to LMAX minus 10 decibels. Let's call this range like max minus 10 dB, so that again that I know what kind of ranges are selected within the new marker. And what we have now is this new marker, LMAX minus 10 dB. It in this case particularly, it's quite similar with our initial selection. However, no, there's just one more sample selected here, and it's most likely due to the fact that we are now catching ranges like 10 dB from maximum level. Let's have a look at one more case to see how it behaves in various situations. Like here we have pre-selection in this range, and then maximum level minus 10 dB looks slightly different. The important difference is that this is like matched with the regulations, and it's the formal way to evaluate such events. So we are now quite free to go to calculate the actual parameters we need to report on, starting with let's say SEL for the default parameters, and for each event selected with our Lmax minus 10 dB marker, we will calculate the SEL value. Calculate, alright, here the new function appeared, SEL, for this event. We can have a look here to get, yeah, now I'm just interested in SEL, so I will switch off other functions from the configurator menu. So now I see SEL values for each event that we have previously selected. This is exactly the way that you will probably need to report on SEL values in a report on airport noise monitoring. And to continue with finding LVA values, we will go back to the calculator tool. This time we will select the calculation of LVA functions. The LVA function is defined over 24-hour periods of time, so that's why the 24-hour interval calculation option is a must. And what we need to do is again to choose to calculate over the selected the found events of aircraft passing. Okay, that's quite it. Calculate, and again the most convenient way to see LVA values will be in table form. I will deselect the previously viewed SEL functions and switch to cumulated view mode, which is most suitable here because it just aggregates these results into a very neat table. Which shows us for each day of our measurement the daily LVA, daily daytime LVA, and daily nighttime LVA values. This is also some data we will need to report on when analyzing airport noise measurements. Okay, this is quite it in this tutorial. Feel free to ask questions to SvanTech about some other options of searching for events in this area. Thank you very much.